Notes. Okay, so we're doing the notes now. I'm recording, so if you got questions, feel free to ask still. But let's keep the side chatter to a minimum, please. Actually, to 0. Okay. All right, so solve the inequality here. So to solve the inequality here, it's giving you that rule right away. We have to divide by a -2. So as soon as we divide by this -2, we have to flip the inequality. So we're going here, here. That's an alert, whatever, an alert sign. Okay. That's going to be x. That was less than. Now it's greater than. That's -4. Just in review, if you're doing the number line, open dot, greater than. Open dot because it's just greater than, not equal to. Solid dot if it's equal to. It's just a solid dot. So just be like, it'd be that. Yeah. Okay. Okay, and then I'll put this on here for those of you guys who are gone yesterday, and it's probably good for the video. Remember yesterday we talked about you need to know your symbols. So you know your open dots, okay, are going to be less than, greater than, and not equal to. That's your open dot symbols. Your closed dot symbols, right, less than equal to, greater than equal to, and simply equal to. Okay, that means they can be that number. Okay. And if you want to write up here, whatever, I'm not going to write it here just because one, my handwriting's bad and we already did it yesterday. But the rule is flip if you divide or multiply by a negative. You have to flip the inequality. Okay, we talked about that yesterday. Okay, so then to show you notes here, we'll go through these quickly. We're still in the easy section. We'll get to a little bit more difficult stuff in a second. Divide by -8, divide by -8. Alarm goes off. I'm dividing by a negative, so I flip that greater than to less than. I have x. -64 divided by -8 is a +8. Doesn't ask me to do the number line, so I won't do it every time. Okay, this would be an open dot to the left of 8. Divide 4, divide 4. Not dividing by a negative, so nothing changes. Is less than, we can simplify that to 5/2. 10/4 reduces to 5/2. Can you not write 2.5? You can. Okay, any questions there? Okay. So now we got this one. So these are just the simple 1 steps with addition and subtraction. I have x minus 3 greater than 2. They put this here because they want you to see the minus. The minus, we're still going to add to get rid of it. So that does not make us flip anything. So that's gone. X greater than equal to 5. That's all. Okay, x greater than equal to 5. Okay, remember if you guys got questions, ask if everybody can hear them. Yeah.
Well, if it is -12 is greater than x over 3,
Yeah.
and you multiply -12 by 3, do you still flip? Or
No, because that 3 multiplied by is positive. Good question. Okay. All right, so here we go. X plus 7 greater than or equal to 5. Minus a 7, minus a 7. X greater than or equal to, that's a 7 there. -2, just stays there. X minus 1.6, add 1.6, add 1.6. Don't have to flip because I added. That's going to be -4. Any questions? Pretty standard right now. All right, let's keep going here. Okay, so now we're getting to a little bit more what Luke just kind of asked. Here's an example. So we have x over 3. So, and it's on the other side. So remember, I said if you hate the x being on the right side, that's totally fine. You can simply rewrite it right now like this. It's the pointy sides towards the x. I keep it towards it. This is the same thing. So you can just rewrite it. If you want to get right to normal, you can rewrite it right now. Do you have to? No. You can still solve it either way. Okay, we'll want to take a vote real quick. Do you guys want us to always flip it to this side, or do you just want to keep as is? All right, so raise your hand if you want to flip. Okay, so it's about half and half. Okay, you didn't make that easy. So I'll kind of do both. It's not a big deal. I'll do both, all right? So here we go. Times 3 times 3. Again, this is like what Luke just asked. I'm timesing by a positive. I do not flip. Yeah. So that's your answer there. Okay, for the ones that you flipped. Times 3 times 3. Okay, these are the same thing. X less than negative 15, negative 15 greater than x. They're the same exact thing. You can choose what you want to do. I think the biggest thing I don't want us to assume, okay, the biggest thing I don't want us to forget is that this is written as a fraction, but that bar simply means division. Okay, right? That's a dividing bar. So don't think that, oh, it's a fraction, I don't know what to do. Think, oh, that's x divided by 7. I multiply. That should be your thought process. Okay, so 7, x less than equal to 84. I don't flip or anything because it wasn't a negative. No problems there. I just know that 7 times 12 is 84. You might not know it off the top of your head, but it's on your Mad Minutes. Hey. Yeah. All right, so for B, Emily, are we going to flip on B? That a girl. Timesing by negative 8 times by negative 8. That should go off as a flip. That cancels. X less than negative 24. Okay, we times by a negative. That's huge. Okay, I'm going to have to move it up here a bit. I'm kind of out of room. Okay, move this up. So those of you that like to flip, you can go ahead and flip there. Okay, so remember, if you're going to flip, I'll do it, but you should have this. That's what you should have if you flipped. It's totally fine. Times by 3 to both of them here, to both sides. I'm timesing a positive 3, so I do not have to flip. So negative 36 is greater than x, or x is less than negative 36. Both answers are acceptable. No. I flipped the equation over for people that like the x on the left. You don't have to do this. This right here is like optional.
No, but in the equation you can flip because you're multiplying it by a negative 12.
No, we're multiplying by a 3.
So even if it's multiplying by...
Okay, guys, right now there shouldn't be any side chatter, okay? There's a question from a classmate. You should listen. Shh, Stewie. You should listen, okay? And stop with the side chatter. So I'm talking about. It makes it very difficult for everyone to participate. Okay? Okay, so, Jack, what did we multiply by? 3, and that's a positive.
Yeah.
So therefore, we do not flip. It doesn't matter if this guy's negative or not. Okay? That's a very important confusion point. Okay? That's why I want everybody to listen. Okay? You got it? You good? Okay. So here, we multiply by the negative 10. Now we're going to flip. Good. I actually forgot to just right there for a second. 20. Negative 2 times a negative 10, it's a positive 20. Okay? All right. Let's look and see here. So, example 2, Trevor solved the inequality, negative 2x greater than 11, greater than or equal to 11. He showed his solution. On number line, verify if his solution to the inequality is incorrect. How can we verify if it's correct? Let's just say we might know it's already wrong, but how can we verify? Luke?
By putting negative 5.5 into the equation.
Okay, good, but we actually don't need to, we actually don't need to put 5.5 in. We can put anything bigger than 5.5. I'd go with something easier, because he's saying it's all answers bigger. So I'd probably put negative 5. Let's stay away from decimal, okay? So if I put negative 5 in here, what's negative 2 times a negative 5? Negative 10 or positive 10? Positive 10. Is 10 bigger than 11? No, so he's incorrect. His solution set right now is wrong. Okay? What's something easy I could have tried? What's something bigger than negative 5.5? Yeah, 0. What's negative 2 times 0? 0. Is that bigger than 11? No, so he's incorrect. What did he do? He didn't flip. He divided by -2, but he forgot to flip the sign. You see that?
You really wouldn't even have to use an underline. You could just solve it and just see if it's wrong.
Correct. Okay, so it should be less than -5.5. Okay, less than equal to -5.5. Okay, verify whether the Trevor's solution is incorrect. We already did that, so we are good. We fixed it. All right. So we got these guys. Verify the solution again. Okay, so Connor, what number would you try for x less than 32? So like if this is the answer, what number would you try to verify? X less than 32, anything? 31, all right, so 31. 31 minus 12 is 19. Is 19 less than or equal to 20? Yeah, so this one is correct. The only thing that's wrong is what? They did change something for some reason.
There should be the bottom line.
Yeah, it has to have the equal to. There's no reason to lose the equal to. It lost the equal to is all. Oh, it's on yours? Okay, well, good. Then you guys are good. Either way, the solving was correct. So all we have to do is put a dot at 32, a solid dot, and we're going to the left. Okay, we check it. 32 minus 12 is 20. 20 equals 20. It's true. Check the inequality sign. So this one's all, this should all have this equal to here. So all they're doing here is they're saying 12 minus 12, x plus 20. So it's true. Okay. Oh, they wanted you to try, they wanted you to try a number here. So you can try anything you want. This is up to you. 0? Okay, good, thank you. 0 minus 12. 0 minus 12 is negative 12. That's less than 20, so we're still true. Thank you. You guys are ahead of the game. Okay. All right, next one. Inequality. Got to divide by -5. Again, that alarm should go off. We've been saying it a bunch. 30 divided by -5 is a -6. Should be x greater than -6. But if we tested what they had, check a number that's less than -6. If I check -7, -7 times -5 is 35, and that's not less than 30. So right there, we've proven that's incorrect.
Wait, so which sign do you use? Do you combine the original one from the inequalities?
So they had less than and less than. They didn't flip, so we just flipped to greater than.
So you do in favor.
No, they kept it less than
For the check.
for the check. We checked from theirs, not from ours. So I tried -7, which is less than 6. And so it ended up making it wrong still. And so this would be a false. And then it says, if the solution is correct, circle yes. If it's not, then find the correct solution. We already found the correct solution. It'd be this. X greater than -6. So for example, we could try 0, right? So if I tried 0, -5 times 0 is less than 30. -5 times 0 is 0. Is 0 less than 30? It is. So we've confirmed that our new solution is correct. Okay. All right, last page here. Well, we got this little guy here first. One more, yep. Okay, so games are on sale for $12.50, including tax. Sean has $80. How many games can he buy? So he has $80. $12.50 per game. So what would that inequality be? We're not doing equals. We want it as an inequality.
Less than or equal to.
Right. He can spend less than or equal to $80. He has $80, so there's a range of how many games he can buy. Okay, so if we divide this by 12.5, okay, what's 80 divided by 12.5? It's going to be a decimal. 6.4. So here's the deal. 6.4. Is video games a continuous or discrete number? So we talk about that. Is it like shoes or is it like temperature?
Shoes.
It's like shoes, right? We can't have a 0.4 of a game. So what's the most he can buy? 6. And so we can also say equal to because he can buy 6. Okay. Is there another way you could write this that would make sense? How about, are these different? That works too, right? Because we know that we can't have a decimal. This is saying less than 7. So it means he can't buy 7 games, but he can buy as many as he wants below 7. This means 6 and lower. So they actually mean the same thing. Okay, so both of these work. Okay, why they work is because this is not a decimal possibility. So what is the next number less than 7? 6. We can't be 7. That's what this is saying. That's why it's not equal to. This one says 6 and lower. So they do cover the same amount of games. 6, 5, 4, 3, 2, 1. And then obviously none if he doesn't want to buy any. Okay? Now if we're being tic-tacky, what would we really want to make sure that we know, like what's the limit the other way? What's the smallest amount? 0, right? We can't have negative games, right? So you'd want to say make sure that you understand he can't be 0. I'll be right with you. Okay, so, all right, here we go. Last one here. Okay, so Yvonne is planting trees for a summer job. She is paid 10 cents per planted tree. She wants to earn at least $20 an hour. How many trees must she plant per hour to achieve her goal? Write an inequality to model the problem. Let n, the number of trees she needs to plant. Okay, payment for n trees equals n. Earnings must be at least what? What's the inequality? Okay, so payment for n trees. How much do you get paid per tree? 10 cents. So you put 0.10. Earnings must be at least 20. So your inequality is 0.10 greater than equal to 20. So we're figuring out how many trees she has to plant to make what she wants to make. So we set it up now. 0.10 n. We're going to divide. $20 divided by 0.10. What is that? 200. So she has to plant 200 trees an hour in order to get, hopefully she has some type of device, huh? So 200 trees per hour. Wow, that's a lot. Okay, 200 trees per hour. It's really drilling the holes quickly. Okay, all right, so you guys have your packet time now.